Welcome, everyone. Good morning, good afternoon, good evening, depending on where you are. My name is Joachim Arts. I'm a professor at the Luxembourg Center within the Skill Network, and I'm covering for Professor Mantin, who unfortunately was found ill today. In the spirit of global logistics, we have assembled an amazing portfolio of speakers from 3 different continents, spanning numerous time zones, and accordingly, we are expecting a broad audience from around the globe to join us. Listen and learn from this inspiring webinar. The topic of the webinar today is moving from the global to the local, and we will focus on city logistics. I guess many of you are commuting to your workplace on a regular basis and are quite familiar with the notion of congestion and how it impacts your daily commute. Put yourselves for a moment in the shoes of the delivery persons, those truck drivers who bring the goods to the retail store so that you, the consumer, can frequent these stores and buy your food, drinks, medication, garments, electronics, and so forth. For these drivers, the task of delivering the goods to their final destination, scattered around the city, can be a massive challenge, as roads may be busy, stores may not have dedicated loading zones, and if they do, they may be occupied, all of which requires the drivers to spend additional time driving around before they can park and deliver. And this is something they faced most of the day. This challenge impacts cities around the globe. So for such a global problem, it is intuitive to stitch together a webinar featuring international expertise and diverse experiences. We have today 5 speakers, and let me introduce them from east to west. From China, we have Dr. Pascal Wolf, an associate professor at the MIT Global Skill Network Ningbo's China Institute for Supply Chain Innovation, NICI. In his research, Pascal has partnered with stakeholders from the automotive, manufacturing, and logistics industry, and his focal interest is on data-driven technologies to improve supply chain planning and logistics operations. Welcome, Pascal. Moving to Europe, all 3 speakers are from the same time zone, despite being from very different countries. More on the eastern side, we have Patrik Hudek from the Czech Republic. He represents X, an IT and systems integration company where he helps businesses unlock their hidden potential through digital transformation, cloud, AI, and virtual reality solutions. Welcome, Patrik. From Luxembourg, we have Dr. Laura Palacios Arguello, representing the Luxembourg Center for Logistics and Supply Chain Management. Dr. Palacios is a research scientist at the LCL, and she leads the City Logistics Freight Lab. She is also a research affiliate of 2 MIT labs, and importantly, she's the scientific project coordinator of a Horizon Europe project called NextLogic, involving 35 partners. Welcome, Laura. Further in Europe, we have Dr. Beatriz Royo from the Zaragoza Center for Logistics in Spain, where she's an associate professor specializing in transportation decision support systems and digitalization. Last but not least, Dr. Juan Carlos Piña Pardo is joining us from the MIT Center for Transportation and Logistics in the US. He is a research affiliate of the CTL and assistant professor of industrial engineering at Pontificia Universidad Católica de Valparaíso. I excuse my Spanish. His current research focuses on designing and optimizing transportation and logistics systems under uncertainty, with an emphasis on urban last mile logistics. Now that you know the speakers, we can transition to the more interesting parts. Each of the speakers will present for about 7 minutes. And at the end, we will have some questions and answers. Please prepare your toughest questions. The order of the presentations will go from broader solutions to more specific ones. And so we will start with Beatriz, who will talk about digital twins in Madrid. Then Pascal will walk us through an implementation of parcel lockers in Asia Pacific. Juan Carlos will tell us about Microhubs in New York City and the adoption of cargo bikes. Laura will educate us on smart loading zones and how to transition from pilot to long-term implementation. And finally, Patrick will showcase use of sensors and digital tools for cargo bikes. Okay, so you know what the plan is. I now give the floor to Beatriz.
Thank you for the introduction. So let me share the screen. So I guess that you can see now. Okay, so well, as I mentioned, thank you for the introduction. So now I'm going to explain the development and results of a European Union project that took 3 years. It finished in 2023. It was about developing digital twins for replicating different new business logistics models across Europe, but in this case, we are focusing on Madrid now. Yeah, Madrid, as most of high-density populated cities, suffers the negative externalities of urban mobility and specifically regarding the transport and logistics. These operations are not efficient. So as the solution in this project, we implemented a urban consolidation center in order to deliver parcels to the e-commerce consumers in the city center of Madrid. In parallel, we developed a digital twin for providing optimal route plannings, but also to evaluate the impact before and after the implementations, and also explore alternative scenarios virtually. So this image illustrates the network and it will help me to explain the before and after operations. So in the business as usual scenario, what they had is the warehouse in San Fernando de Henares that is around 30 kilometers away to the city center. In this business as usual scenario, they deliver directly to the end consumers using diesel vehicles. In the new scenario, the network is divided into two echelons. And the first echelon connects the San Fernando de Henares, the warehouse, with the urban consolidation center in Plaza Mayor using hybrid vehicles. And finally, the parcels are delivered to the end consumers from the UCC using these small vehicles that you can see here. I would like to outline that the Urban Consolidation Center was installed in the underground parking that you can see here, and it was essential to have the public-private partnership between the logistics operator and the public entity that manages the facility. About the digital twin, so the idea was to collect statistical data, so the spatial information, but also the vehicle characteristics. We collected also historic data about the traffic and also external sources of information in order to be able to calculate environmental indicators. But we also collected more dynamic data as the operational daily services and also the available resources. The digital twin then used this information, so process this information in order to provide the optimal routes execution plans, but also to compare the real scenarios that you can see here that are the direct shipments with the diesel vans and the two echelon network shipments by using hybrid vans in the first type and electric scooters in the second type. The three alternative scenarios are the second one that you can see here and was based on using electric vans or replacing the diesel vans using electric vans for the direct shipments, and the other two alternative scenarios are related to the two echelon network, and in this case we're about replacing the hybrid van in the first type with the electric vans in the fourth scenario and with big or bigger electric vans in the fifth scenario. Here we can see the brain of the digital twin, so the combination of models, and this is how they were organized. Okay, so the digital twin pipeline, and everything started with a rough estimation of the resources required in order to the capacity available. With this, the user selected the best combination. So if it was going to be the direct distribution or the two echelon network, and then the route optimization model provided the optimal route planning. And finally, this information was used to calculate environmental impacts, including the noise, greenhouse gas emissions, and pollutants. So as the results from comparing the real implementations, the direct distributions with the diesel vans and the two echelon network with hybrid vans and electric vehicles, we can see that the operational indicators improved and also the environmental KPIs. We can see here that the cost was not affected, and this was because the fuel that was saved was balanced by the creation of new jobs, and they consider that the required increased parking space for the urban conservation center was a negative impact. And here what we can see is a summary of the 5 scenarios. So the first one is the baseline and the real implementation. So basically the direct shipment using diesel vans, as I mentioned. And the third one, the two echelon real implementation. And we can see here that the operation indicators improve, except the number of vehicles. In the second scenario, that is the virtual one, using direct shipments with electric vehicles, we see as the operational indicators doesn't improve because basically the capacity and the speed and so on is the same. But as the content of the energy source is lower, the environmental indicators improve. And similarly happens with the two echelon virtual implementations. So in the third case, only the environmental indicators improve regarding the real implementation with the two echelon network. But in the fifth case, as we are using bigger vehicles for the first time, these indicators improves slightly. Just to mention that this was considered as one of the best practices by the EIT Urban Mobility. And just to finalize this good value, okay, so this was a valuable pilot in order to scale the network to another hubs and to finalize that was the first city digital twin in Madrid. And this is all from my side.
Thank you, Beatrice. Well, then let's move on to Pascal, who has one solution to improve the parking space problem that is one of the open questions still. Pascal.
All right. Thank you very much, Joachim. Could you please give me a quick heads up whether you can see my screen or not? Working? Okay, perfect. Thank you. Yeah, thanks a lot for the invitation today to share some ongoing research in the area of parcel lockers in Asia Pacific. I'm going to share some joint work with my great student Christopher, who graduated from our program just 2 months ago, and we conducted a consumer behavior study in Indonesia, his home country, to see how these parcel lockers can actually be deployed or actually getting into work in Indonesia in the future. With all that being said, maybe most of us might not be too familiar with the Indonesian market itself. So I have here a couple of key facts on the courier express and parcel sector in Indonesia. It's a flourishing sector in Indonesia, still having compound annual growth rates of more than 7%. Currently, roughly speaking, $8 billion market size, about to be more than 11 billion by 2030. The major players in the market, which are not really too relevant for my talk, but some of them you might have seen before, JNE, JNT and Ninja Express are the dominant players there, the major CEP companies. And to give you a couple of further insights regarding besides the market size itself, so roughly speaking, 50% of the shipments in Indonesia are actually B2C shipments, and roughly a third of it is coming out of the e-commerce sector. So what makes Indonesia a little bit special, particularly when you compare it, for instance, to China, is that the majority of shipments is actually so-called non-express deliveries. Means they are not too much into fast shipments yet. And this is mainly due to the budget-conscious customers there. So this is the dominating group in Indonesia, which results then actually in slower delivery times. Also, of course, because of the geographics with hundreds of islands in the end. Now, with the growing CEP sector and the growing e-commerce business, of course, the last mile challenges are also then actually amplified. So Joachim mentioned them in the beginning. We have congestion in urban areas. We have inefficiencies in last mile logistics. We have, couriers, which are actually basically overworked, right? So it's a super tough job. And also then, of course, we have the issue that the consumers are not necessarily satisfied because the courier might show up at your home when you are at work, and therefore you're missing each other. One potential solution to this problem, and this is nothing new in, for instance, Europe or China, is to simply use smart parcel lockers to overcome most of these challenges, right? So you're having actually another shipment point, just a locker, and the courier is actually dropping the parcel for you close by, ideally to your home in such a locker, right? To give you a couple of statistics in other parts of the world, in the European Union, we have more than 160,000 of these smart parcel lockers at the moment, and this sector is actually growing quite a bit. So we have 30% growth rates year on year. What is a little bit of a boundary there is that these systems are often closed loop systems. So think of the Amazon system. So in that regard, they are only dedicated for Amazon shipments. In China, on the other hand, these systems are usually carrier agnostic systems, so open. Every logistics company can use them against a small delivery fee. And in China, as of today, more than 50% of the entire shipment volume is going through these parcel lockers or delivery stations, which are then also hosting such parcel lockers. So they are deployed here quite substantially. And we wanted to actually check how this could look like in the future in Indonesia. Now, to give you a couple of thoughts on why these parcel lockers often make sense, well, they come with quite a few of advantages, obviously. So first of all, I mentioned that it might not necessarily be the case that you are at home when the courier is showing up to drop the shipment. And in that case, you are having a missed delivery and he has to come again. In China, just as an example, a courier is having per day more than 200 deliveries, and he's making out of these 200 deliveries more than 120 phone calls. So alone for the phone calls, they are wasting hours every day to check whether you're at home or not, right? So with the parcel locker, this is actually something you don't have to deal with anymore. Then, of course, parcel security is a thing. So if they are just dropping it on your doorstep, in that regard, it might get lost in the end, stolen. And of course, parcel lockers are also coming with cost saving and CO2 saving potentials, because instead of individual shipments to your home, you are actually having a bulk shipment to such a parcel locker. And in that regard, we are reducing the number of shipments, and we have actually a consolidation effect, so to say. Now, what is important to keep in mind whenever we are talking about parcel lockers is that to make such a system work, you need the consumer to actually participate in it, right? The consumer has a role and needs to actively engage, okay? And there has been a lot of research, especially in Northern Europe, particularly, and in Singapore, how you can actually nudge or incentivize consumers in order to contribute to such a system. And some of the main factors that were discussed are obviously financial incentives, that you just say, okay, the delivery fee will be lower. Or also then, of course, the distance makes a big impact, right? So if the parcel locker is further away from your home, you might not be too eager to actually go there, right? And last but not least, the accessibility is a thing. So whenever this parcel locker is in a shop or office building or so with limited access, of course, this becomes inconvenient for end users, for instance, when it's during the business hours. So what we want to understand is in Indonesia, what are the driving factors in order to nudge consumers to contribute to such a system. So we designed a factorial survey where we considered the distance, the financial incentive, and the parcel locker accessibility, and checked how it impacts actually the willingness to use such a parcel locker. We also controlled for several factors, but I'm not going, due to the time difference, too much in detail there. All in all, we had 343 samples in our study in the end. To show you a couple of results or insights, first of all, I want to report on the main effects. So we had a look at the financial incentive and how it impacts the willingness to use a parcel locker, the distance, and the accessibility. And for the financial incentive, you see if we are increasing that, so if we are offering more of a refund for the delivery fee, the consumer is more willing to participate. And this was almost a linear effect, actually. For the distance, what previous research showed was the further the parcel locker is away, the less eager you are actually to go there, right? That makes sense. What we found in Indonesia, on the other hand, is that this is true when we are increasing the distance from 100 meters to 400 meters. But then we saw that it's kind of dropping back when we are going to 800 meters. I will come to that in a second and explain that a little bit further. A major driver of the willingness to actually use such a parcel locker was definitely the accessibility. The business hours, when it's only available during business hours, this is really a hindering factor, and it must be available 24/7 to make it convenient. Talking about this impact of the distance, I have here also the interaction effects that we report on. The interaction between the financial incentive and the accessibility, as well as distance and accessibility. What we see for the financial incentive is that in a case where it's available 24/7, we have almost this perfectly linear effect. The more financial incentive you provide, the more likely it will be used. However, for a setting where you only have the parcel locker available and accessible during business hours, this effect is actually phasing out. So you cannot actually set off the inconvenience of only having it available during business hours when you are at work by yourself, right? Then to talk a little bit more about the distance here and accessibility, you see for the red line that it's bouncing back when we are increasing the distance. We also had a couple of post-survey questions there in our experiment. And what we actually figured out is that consumers are more willing to go for an 800-meter distance because they are then actually using the motorcycle or a car, actually. So in that regard, the transport mode, the choice of transportation, is actually then making it again more convenient because 400 meters is considered walking distance in Indonesia, and 800 meters is something you would do with a motorbike, actually. Where are we heading in the future? I mean, we are already seeing in different countries that mobile parcel lockers are on the rise, or at least tested. So in China, autonomous settings where such a parcel locker can travel around the city. In Sweden, they have a pilot where it's basically a trailer which is then manually repositioned throughout the day. That is actually quite nice because some previous research showed that by having such a mobile parcel locker, you can significantly reduce the required capacity. So you need much less storage space in order to satisfy and fulfill the customer demand. With that being said, just a quick wrap up, keep in mind whenever you are actually designing these systems or think about deploying them, financial incentives are nice, but there's more to it. Keep always in mind the network and especially there the accessibility to these parcel lockers, and it must be also adapted to the local context. With that being said, thanks a lot, and I'm happy to take some questions if we have time.
Thank you, Pascal. I actually saw that Beatrice also started answering some of the smaller questions in the chat. I encourage the other panelists for easy questions that are easy to answer in a few lines to do the same. In the meantime, we will move on to Juan Carlos, who will talk about microhubs in New York City. So from Madrid to Indonesia, now to New York City.
Can you see my screen? Yeah, okay. Well, thank you so much for having me. My name is Juan Carlos Piña Pardo. I am an assistant professor at Pontificia Universidad Católica Valparaíso in Chile and a research affiliate at the MIT Center for Transportation and Logistics. And today I will be talking about how cities can create more sustainable city logistics systems using Microhubs. And for that, I will take as an example the case of New York City. So according to the New York Times, more than 2 million parcels are delivered daily in New York City. What is the problem? The problem is that currently 90% of those deliveries are conducted by regular conventional trucks. So, for example, some of the problems we see on the streets in Manhattan are first, on-street sorting and transloading of orders. Second, double parking. And third, large trucks driving through narrow streets. So in response to these issues, the New York City Department of Transportation recently announced a pilot program to test microhubs. Microhubs are basically dedicated spaces, not necessarily a facility, but a specific space where operators can transfer goods from large vehicles to sustainable vehicles, for example, a cargo bike, for last mile delivery. In particular, they are considering two concepts. First, on-street microhubs. And as you can see here, the idea is to repurpose a public parking space as a microhub. And you have here the big truck unloading the orders, and then the orders will be transferred to the cargo bikes. And also they are testing a similar concept. They are calling off-street microhubs, for example, under a bridge. So you have the trucks parking here, and the same, transloading the orders from the trucks to the cargo bikes. So what I will present now is a joint work with Professors Jean Boucherie and Walid Clini from Ketch Business School in France, in which we are addressing the sustainable last mile network design with microhubs under competition. And the main question we have is how cities can create more sustainable city logistics systems. And what we believe is that based on actually from research and also practice, is that creating sustainable last mile logistics systems demands considering the conflicting objectives of all stakeholders. So from one side, for example, we have municipalities or local authorities who are interested in mitigating the negative externalities of city logistics, for example, traffic or congestion. And on the other hand, we have logistics service providers or operators who are interested in minimizing costs, finding cost minimizing distribution strategies to meet demand. So what we did in this research is to create a single mathematical framework capturing all these goals simultaneously. And for that, we use a concept from game theory, which is called a Stackelberg game, in which the idea is to conceptualize the problem as a game. So in this game, we have two types of players. We have leaders and followers. In our case, the municipality or local authority is the leader who moves first by deciding the location of these public microhubs. And then we have the followers, who are the operators, who then react non-cooperatively by deciding their own cost-minimizing distribution plans. So this is the way we conceptualize the problem. And in order to formulate the problem mathematically, we use a stochastic level optimization. And for that, this is basically a way to model this in mathematically these hierarchical games in which you have an upper level problem and a lower level problem. So in the upper level, we have the municipality problem. And here the municipality aims to find the location of these public microhubs in order to maximize, and this is the objective that we are considering, maximize number of sustainable deliveries. And the key here in this mathematical formulation is that the municipality do so by explicitly anticipating the optimal reaction of the followers, the operators. So the municipality is taking into account this explicitly when deciding the location of public microhubs. And then in the lower level problem, after the municipality makes a decision, and specifically once we have a given demand realization, the operators compete non-cooperatively. In this case, this is basically technically a Nash equilibrium problem, they compete in order to use these public microhubs. So there is a space competition. They compete to use these public microhubs to minimize their distribution cost. So in order to get some insights, what we did was to create a comprehensive case study based on the New York City Department of Transportation current microhub pilot program. And in order to do so, what we did was to consider as a service area Manhattan. And in this service area, we consider first 4 main last mile logistic operators, UPS, Amazon, FedEx, and USPS, who compete for use these public microhubs to minimize their cost. As a public microhubs, according to the New York City Department of Transportation microhub pilot program, what we did was to consider as a potential location for these public microhubs, city-owned properties. And these will be shared locations that can be used by multiple operators, and they compete to use them. And we also consider some the private logistic facilities of the operators that are inside Manhattan as private microhubs. So each operator in our case study has at least one private facility to transfer goods. So the first insight we get is that not every public space needs to be repurposed as microhub. As you can see here in the plot, what we have here in the horizontal axis is the percentage of the total available space that is allocated to microhubs, and then you have the percentage of sustainable deliveries in the vertical axis. So here, 2 insights. First, this good news for a municipality. There is diminishing marginal returns, meaning that here in this particular case, around 30%, you reach the plateau. So you don't need to open more than, you don't need to repurpose all the available space you have. You need to decide strategically where to put these microhubs. The optimization, the stochastic bi-level optimization model we developed actually provide a good balance between depot connectivity and customer proximity. So as I showed before, we consider that the depots of operators are located outside Manhattan. So as you can see in the plot, first we have off-street microhubs. These are the spaces actually under the bridge, the bridges that are here in Manhattan. And these are particular locations that are very, very well connected to the depots, which are outside Manhattan. But also we have on-street microhubs, which are near high demand areas. So just to conclude, first, this is something that is very pragmatic and practical. Municipalities can repurpose existing city-owned spaces into shared microhubs. And in order to decide the location of these public microhubs, what we did was to develop a stochastic bi-level optimization problem that the key aspect is that we don't want to neglect, we don't want to ignore, we want to explicitly anticipate the optimal reaction of the operators. And the main insight that I am sharing now is that not every space should become a microhub. We need to focus on those that are near depots and demand. Thank you so much. That is my presentation.
Thank you, Juan Carlos. All right, Laura, the floor is yours.
Thank you, Joachim. Do you see my screen? Yes, okay, good. So today I will talk about smart loading zones, a freight parking space for sustainable urban deliveries. And I would like to start my presentation with these pictures that actually shows the problem, the issue that we have on carpet space in many cities around the world. So I imagine that this situation happens to all of us at least once in life. That is, you are walking on the street, there is a freight vehicle blocking your way, so you are forced to step on the roadway. Or as a driver, that there is a freight vehicle parking, making double line, blocking your way. So this is the main issue that we have And good transport, of course, is a key topic on urban logistics, especially with e-commerce, is increasingly attention, especially from local authorities. We all know that the last mile deliveries have some negative aspects, such as 30% of urban traffic areas, 25% of CO2 emissions, 20% of total delivery cost, among others, which have forced local authorities to propose some regulations. So they are becoming more and more restrictive, especially on technology of those vehicles, or restricting the access during certain time of the days. So cities actually are observing dramatic increase on vehicles demand for curb space. So the question here is how to manage curb space for freight operations. And for that, we have a couple of solutions to manage curb space in a more efficient way. So from policy perspective to technology use, data inventory, digitization, among others. So here in the map, you can see that there are different cities around the world that have established different policies. We have Paris, London, Washington, Bogota, among others. Bogota and London have established projects and proposals for off-hour deliveries incentive. We have Paris, Gothenburg, Big in Barcelona, who are limiting the use of loading zones for a maximum certain time of the day, or using technologies such as check-in, check-out for the curb space. We have also the example of Vienna using dynamic management system to keep lower the price in commercial vehicle loading zones. So after mapping all these solutions, which of these solutions can be actually implemented to improve the management of freight parking space for loading and loading operations? So that is the central questions. And is one of the questions that we have in Next Logic project. So Next Logic is a Horizon project funded by the European Commission. It's a 4 years project starting next year in January, where we have 35 partners from 13 European countries, 8 cities, 2 organizations, European organizations, 12 industry partners, most of them technology providers, 12 universities, and 1 research center. I'm especially proud to highlight the Luxembourg partners. So the City of Differdange, Cluster for Logistics, Lux Mobility, LIST, and University of Luxembourg, who will lead this project. So Next Logic is combining all these 35 partners with a central goal, which is co-design, co-develop solutions that rethink urban space, improve people's mobility, and address different needs of the cities, such as reduce of congestion pollution, increased electromobility, the better use of vehicles, freight vehicles, the data-driven decision-making, dynamic use of the space, urban space revitalization, and increased accessibility. Among the tools, we have the digital twins, the smart rewards systems, and extended reality. That last two is more on influence the behavior of the people, especially in the freight operators and the pedestrians. And in the solutions, we have mobile microhubs, as presented previously by Juan Carlos, the smart loading zones for smart dynamic curbside management, and 15-minute city and electromobility as the other 2 solutions. But let's talk about the smart loading zones. So for this, we will partner with Park and Load, a company based in Europe that provide this system that actually is provide real-time visibility and occupation and availability to book these zones. So especially is a solution oriented for the drivers, for local authorities. But the idea is that for drivers will not make multiple detours as they know where to park in efficient way. Park and Load have tested this technology in several European cities with very interesting outcomes. So the reduction of parking rotation by the increase of 30% of parking rotation, increase of the parking availability by 30% as well, and reducing by half the misuse of parking. So you can see here a picture of Luxembourg, the city of Luxembourg, where the idea of next logic is the use of the curb space for different stakeholders. So here is an example how the restaurants can use the curb space, the loading and unloading zones, for giving space for the customers to eat, but at noon. But before it can be used by freight vehicles to make their loading and unloading operations. These smart loading zones will be piloted in 4 of our 8 cities. So The Hague in Netherlands, Differdange in Luxembourg, Heidelberg in Germany, and Bergamo in Italy. So you can imagine that these cities are very different with different structure, but it is to how different factors that will drive and hinder the success of the piloting to long-term implementation. We will consider some organizational, technology, regulatory factors to long-term implement this solution. So looking forward for making a real impact in these cities by using these smart loading zones as a technology. Thank you, Joachim.
Thank you, Laura. I'm excited to see the outcome of the project. Patrick, who is actually a part of the project, will discuss how sensor technology can help here. Patrick.
Thank you very much. I hope you can all hear and see me. I will share my screen very quickly and then we can get going. Okay. Great. So you should be able to see my screen, right? Okay, that's great. Also, thank you to Laura for introducing the Next Logic project. I'm here first and foremost as a EXE representative, and we are very lucky to be one of the 35 partners that are taking part in this project in using these modern technologies like virtual reality and digital twins for enhancing urban logistics. And I would like to talk more about in my 7 minutes here about the concrete projects that we will be implementing also with help of our partners that are included in the Next Logic project. For us at EXE, we have multiple years of experience with utilizing the extended reality technology and digital twins, mainly in the applications for industry, but also for cities and utility segment. And it's very good technology to use for such use cases, since it allows for some very interesting use cases, which will be utilized in the Next Logic project. And I would like to talk about them a bit more because every single one of them is addressed in the project. So where we are talking about the virtual reality, there are talks about numerous trends currently, also with the use of artificial intelligence, but it can be boiled down basically to these 3 parts, which are first and foremost very well utilized with the use of virtual reality technology. That would be some simulations and also digital twin as these sort of underlying platform and this umbrella to which you can upload numerous amounts of data, both I would say physical or visual data, but also a lot of big data, like for example, logistics orders, etc., and connected in this software environment. It's also connected to the enhanced visualization of data, whether it's in the virtual reality or sort of this extended reality. We can use our phones that we are carrying in our pockets and utilize this data in the environment around us. And then there is a training and education aspect to it as well. And all these 3 are utilized concretely in the Next Logic project, and I would like to dedicate the next few slides about quickly talking about them. So starting with the virtual simulations and digital twin, these are all applications that we are developing on our own platform, and we will be collaborating with other partners to pilot them and then implement them in the cities inside the Next Logic projects. One of them is strongly focused on the last mile logistics and the utilization of microhubs and cargo bikes in cities for city logistics. So that's a very great use case for such digital twin, which is focused on the scale of a whole city, basically. So you can take a 3D model of a space, include some data from IoT sensors. In this case, it will be a combination of GPS enabled or GPS tracked cargo bags used for the last mile logistics, but also some additional informations, for example, from the Microhubs, like for example, data about shipments, different coordinates, navigations for the cargo bag operators, etc., and combine them in this virtual reality platform and digital twin platform to monitor the fleet in real time, but also gain insights into some historical analytics, like for example, visual analytics of the different shipments and whether the path that it was taken to deliver the packages was the most optimal one. And these data can then be included in the simulation module that's part of the digital twin solution to optimize future shipments, and to provide some more optimized logistics inside the cities. And what's also important is that, and that's why there is a lot of partners in NextLogic project, is that the solutions can then communicate with each other. So there is open API in place, and there is very, very great potential for some external collaboration as well, also in the future behind the project lifespan. Next one is also connected to the digital twin technology, where we will be using the IoT devices, especially object detection cameras. This is a very nice use case, not focused on logistics, but rather on some urban planning and monitoring of for example, bike situations inside the cities, both public bikes, but also bikes from vendors. So there will be cameras in place to monitor occupancy in real time, and this will be then input into sort of a digital map to monitor the trends, monitor the occupancy, also some dwell times and other analytics for these specific parking location and parking spaces. And here, what's really important is then the integration, because the cities can utilize these data to then communicate them to vendors of the bike sharing platforms, for example, but also other companies and partners in the NextLogic project, which will be using the data for gamification or incentivizing the users, for example, to use some parking spots that are less occupied when there is an event taking place, for example, to help with the congestion, help with the urban logistics. And last but not least, we'll be also focusing on the training and education and bringing our expertise in the areas of simulation and training in virtual and mixed reality, since we will be working closely with the digital twin for city logistics. There is also a great potential in scaling this for new cargo bikes operators to help them train on the real environments, but in a safe space and safe environment where they can, for example, train some unexpected situations, and also to utilize the digital twin data to optimize their routing, optimize their sort of operation of the cargo bike. And this will be done by a physical cargo bike simulator where we take the physical hardware cargo bike, but connect it to a software platform like this one, for example, which can then model a real city utilizing the tracked digital twin data, and to put them through a training scenarios with some real-time objects like cars or other occupants, other citizens, etc. Yeah. So this was an overview. I will be more than glad to answer any questions, and thank you very much for your attention.
Thank you, Patrick, and thank you to all speakers. We have some time for questions. Some were posted in the chat, and some of them have already been answered in the chat. There's some questions that were posed that I think merit a bit of a longer discussion. So if I'm stealing your question, I apologize. The first question will be to Juan Carlos, which is about the role of cooperation and competition, right? So you assume that operators compete among each other. An alternative model would be that they somehow cooperate, but if they cooperate, they are different companies, so that obviously has some problems. What are your thoughts on competition versus cooperation, how you model it with, I guess, competitive and cooperative game theory, and what might be hurdles in practice to go for either model?
Yes, thank you so much for the question. We decided to model the setting as a non-cooperative setting because last mile, as I mentioned in the chat, is highly competitive. So operators are interested in finding ways to minimize costs. So this is why the idea of the research is to capture that competition that is usually neglected when, for example, a local authority aims to do a solution or an initiative in order to improve city logistics. So we decided to model the last mile as is, but for sure, some regulations and other aspects could be imposed in order to force somehow cooperation. But I don't think that right now that is the way that last mile is working in particular.
Right, thank you. Okay, Pascal, I saw a question about the bottom line. And I guess my question is, you have two bottom lines, right? Operating the system of these lockers induces cost. I'm guessing the reduction of miles as well as the reduction of no customer found also reduces cost. What can you tell us about the bottom line here?
I was about to answer it written, but it's easier to do it verbally. That really heavily depends on the actual circumstances, because these parcel lockers, they shine when you have a certain delivery volume density. So just as an example, here in China, where we live in gated communities with hundreds of households or sometimes even thousands of households within less than 1 square kilometer, these parcel lockers are perfectly utilized and evenly utilized because you always have the shipping volume, right? And it's very beneficial then for the carrier, because otherwise the delivery guy needs to actually go and take the elevator in the compounds, which is a bottleneck in the end, and waste a lot of time waiting and having a lower delivery frequency, so to say. So in that regard, in these settings, you're having big cost saving potentials because you make the last mile so easy and efficient. But the sustainability impact under such circumstances would be lower because you anyway have a bulk shipment into the compound, right? In other cases, then when you take Europe as an example, for instance, a smaller village where I'm from, we also have a parcel locker, but for one village with 5,000 inhabitants. So in that regard, if you are using this parcel locker, you are instantly working severely on the carbon footprint, right? Because you are reducing the driven miles basically substantially, right? So that depends on the actual circumstances. Cannot be answered generally.
It seems your case works out on the bottom line. All right. Well, yeah. Okay. Beatrice, you had some questions that were asked because it concerned the pilot study. What are the most important hurdles you think that you need to tackle to scale to bigger and or more cities to do this type of work?
Yeah, so for me, the public-private partnership. So I think that this is one of the questions that was in the Q&A. And yeah, sometimes how to exploit the facility, okay, that is governed by the public authorities. how they are going to the operators, how they are going to pay for it, okay, because balance the cost, the increased cost of this installation may not be feasible, okay, for the new business models. So this is the key question, okay, how the public-private partnerships has to be managed in order to make the business model feasible.
Right. Okay, thank you. Patrick, your solution requires the use of technology, but the main cities worldwide that suffer from this problem the most, arguably, are these mega cities in what is now called the Global South. How do you see these types of solutions being used over there? Do they need to be somehow adapted? What are your thoughts on that?
Yeah, thank you. How much time we have for this type?
About 2 minutes. No.
yeah, understood. It was it's true, but at the same time, I think a good or a great potential of these digital twin technologies is that they are quite adaptable and scalable to the environment and to the different aspects of the cities worldwide. So whether in one city they can be optimized for using, for example, GPS tracked bicycles when they are available there. For another city, there can be some infrastructure that can achieve basically the same thing, but via the use of different technology, like, for example, visual intelligence or some computer vision. So it's quite hard to boil it down, but a good thing for this is that we are approaching a time where a lot of the technology and also legacy technology can be optimized to input some valuable information for digital twin platforms. And if we find the right formula of combining these different sources, then the solutions can be implemented also in these type of scenarios, and it all is quite scalable, I would say.
Right, clear. Thank you, Laura. You have the project with the stakeholders from different levels. One of the questions that was just posted is, well, who should enforce this? Should policymakers enforce this in densely populated cities, or more generally, who should be the first mover? How do you see this?
Well, I think smart loading zones, it can be a tool for each of the stakeholders, right? So enforcement, of course, is very important. Actually, with my colleagues from Chalmers University, we mapped around 20 projects around the world and aiming to understand how these smart loading zones projects become from pilots to long-term implementation. And one of the key aspects was the enforcement authorities' involvement in this project. So yes, it will be used by local authorities, but also for enforcement point of view, the drivers who will use these to see the occupancy of these loading zones. But for me, it could be like both. As end users, local authorities, but leadership of the needs to come from the city, right? So the users will drive an operational uptake, of course. So the short answer is both.
Right, thank you. We have come formally to the end of the session. It is, well, 3 o'clock where I am. Please change it to whatever time you are at. We are grateful that you were able to attend. The panelists and I will stick around a little bit longer to answer any remaining questions that you might have. But for those of you who need to move on to your next appointment, thank you for joining, and we hope to see you again soon for the next Scale webinar.